Okay. So in number 18, you have a stunt person that he or she jumps from the building. The concrete takes zero point 0.1 seconds to 0.01 seconds to stop the person by applying an average force of 50,000 newtons. If the same person jumps from the building and lands on a cushion, the stopping time is lengthened to 0.2 seconds. What average force is applied to the stunt person in this case? So when you're looking at this, we have to know the impulse and know that impulse is force multiplied by time. And that's going to be equal to the change in momentum of that person. Now, the mass of the person is not going to change in either case, and the change in velocity is going to be the same in both cases. So we have two cases going on. How do we know in both cases that the change in momentum is going to be the same? Well, we know the change in momentum is the same because the mass of the person remains constant, and whatever, and they would have the same change in velocity because it's coming to a rest. Yeah. And they're falling from the same height. So we know that this number is going to be constant between both cases. So we would need to know, I think in both cases they wanted us to, well, let's see, let me look at that. If the same person jumps from the building and lands on a cushion, the stopping time is lengthened to 0.2 seconds. Right. So really we need to know what the change in momentum of this person is. So that change in momentum is the same in both cases. Let's figure out what it is in case one. So in case one, we would need to know the force and the time to find the change in momentum, right? Well, what's the force on that person? 50,000 newtons, and then the time would be 0.01 seconds, and that's going to give us our change in momentum. And if we do that, we find that the change in momentum is 500. All right. Now, when we come to the second case, we already know the change in momentum. What's the change in momentum going to be? 500. We know the change in momentum in case 2 has got to be identical. It's the same person coming to a stop from the same height. So they'll have the same change in velocity. So we know that change in momentum is 500. And let's put units on it. Probably should have put it on it before. Kilogram meters per second. So we know that there's our change in momentum. That change in momentum is also going to be equal to the impulse there. But the impulse, although it's 500, it's going to be a little bit different because the time is different here. So we could say that we have 500 now equal to some new force on it because there is a new amount of stopping time. So let's figure out what that new force is by dividing 500 by 0.2. Then we figure out that new amount of force is what? Is what? 2,500 newtons.
On the thing that you put